Section 8.1, Polar Coordinates. Up to now, all of our graphs have been graphed using rectangular coordinates on the Cartesian plane, that is with ordered pairs x and y. There is also a set of what we call polar coordinates, which is going to relate to angle measure and some radius. Now, the good thing is that if you consider the way we laid out our unit circle, you're heading in the right direction. And so specifically, when we consider this polar coordinate, r theta, then r is the amount that you move away from the origin or the pole, and then theta is going to be the amount that you rotate that point. If you were to consider graphing with rectangular coordinates on our Cartesian plane, you can consider that that's really the idea of a classic Etch-a-Sketch. And so one knob controls vertical movement, the other knob controls left and right, and so the coordinates could correspond to those knobs. Now, if you were to change the way an Etch-a-Sketch worked, and you were to say that one knob did rotation and the other adjusted the radius, then you could use an Etch-a-Sketch in polar coordinates. Now, I called this thing the pole, so the pole or the origin are the same. That's essentially where we start. And then the polar axis is going to be where we begin, which is always going to be the positive x-axis. And so then our theta measurements are going to work exactly the same way our rotations did on the unit circle. Positive rotations are going to go counterclockwise. Negative rotations are going to go counterclockwise. Also recognize that just like we had coterminal angles pop up, coterminal angles definitely occur when considering polar coordinates. So let's just see some points plotted via polar coordinates. And so let's look at point A and recognize that point A here is the point 4, 60 degrees in terms of polar coordinates. That is, it goes a distance of 4, 1, 2, 3, 4, and a rotation of 60. So if you went out to 4, rotated to 60, you would get to that point. B is the point 3 pi. So if I go to 3, 1, 2, 3, and then I rotate an amount pi, where I land, that is the point B. The point C, go a distance of 2, go rotation of negative 30 degrees, rotate negative 30 degrees, that's a clockwise rotation, and we get to the point C. D being 5, 390 degrees, that goes to 5, and then I rotate 390 degrees, so rotate all the way around back to 360, and then go an additional 30 degrees to 390. There we are, that's our point D. Now E we have labeled twice, so notice first that if I have 3, 210, 210 degrees being my polar coordinate, then I would go a distance of 3, and then I rotate 210 degrees. Rotate 210 degrees, I get to this point. Great. So then if I want to plot negative 330 degrees, notice that I do the rotation of 30 degrees, and then, so on that ray there, but then I go a negative 3, and so I end up at the exact same location. Then let's look at F. Recognize that I have it written 3 ways here. So first I have 4, then with a rotation of 285 degrees, so I get over here to 285. Then if I do 4 and I do negative rotation of 75 degrees, I can get there also. Then notice that if I had a rotation of 105 degrees, then I go negative 4, and I end up at the exact same place. And so we've actually written it 3 ways here. Then let's check out G. G is I go out a distance of 6, and then I rotate 3 pi fourths, and I end up at that point G. So let's graph these polar coordinates. So if I have 3 60 degrees, my radius is 3, so I got 3. 1, 2, 3. I'll go ahead and label the rest of these. Then I have my radii measured, and so then 360, go out 3, do a rotation of 60 degrees. There we are, that's 360. Radius of 0 with a rotation of 10, well, if we go nowhere from the pole, then we're going to end up on the pole. Then negative 5, 120 degrees, so go out to negative 5. 1, 2, 3, 4, 5. Then go a rotation of 120 degrees, so we end up right here. There we are. There's our 120 degree rotation. Then if I have negative 6, 1, 2, 3, 4, 5, 6, then I rotate that a negative pi 6, that's a clockwise rotation, and so that ends up right there. Then let's go a distance of 2 from the pole, so go 2 from the pole. Then do a rotation of 3 pi halves, so 3 pi halves rotation ends up right here. There we are. Then let's go negative 4, 1, 2, 3, 4, and then a rotation of pi thirds. Pi thirds ends up then right here. And so there is our point F. That's how we plot polar coordinates. So we want to be able to convert between rectangular coordinates and polar coordinates. And what's important to recognize is that if I take this ordered pair that's given here, remember that that is the point xy. But also notice that it's also the point r theta. And if you consider that r theta and xy have the exact same relationship that r and theta and x and y had before when using the definitions that we gave when considering a circle, then we have everything we need to know about converting. Specifically, let's say that I want to find r. Well, remember that r is really related to x and y. It is the square root of x squared plus y squared because of the Pythagorean theorem. So then we're going to say exactly that. R is equal to the square root of x squared plus y squared. So then let's say that we want to establish some relationship between x and y and r and theta. Well, it's useful to recall that cosine of theta is x divided by r. And if we know that cosine of theta is x divided by r, then it's also true that x is equal to r cosine theta. Similarly, recall that sine of theta is y divided by r. Specifically, that means that y is equal to r sine theta. Also, one more thing that could be useful, that is the fact that tangent of theta is equal to y divided by x, which means that we can get theta is equal to tangent inverse of y over x. In general, if you draw a picture of ordered pairs in the coordinate plane, then you will just draw a triangle and find the pair, the polar coordinate pair r theta, or vice versa. Ends up being exactly the same. So now we want to convert each of the following rectangular coordinates to polar coordinates, and then we want to write it in 3 other ways. And so specifically 3 other ways means I'm either going to use a coterminal angle, because of course there's an infinite number of ways to write anything using coterminal angles, and you can also use negative radii to be able to do this. So let's try this. So, what's the steps? Step 1, draw your ordered pair. So if I have negative 6, 0, there's an xy coordinate plane, and I'm going to plot my point negative 6, 0. So, negative 6, 0, let's just say that's negative 6. So this is the ordered pair negative 6, 0. Now I claim that this one's not too bad because recognize that all we need to now find is r and the rotational angle theta. But I claim that all of that is done. Specifically, we can see that the radius between the pole and the point is the distance 6. And so r equal to 6 works out. If r is equal to 6, then theta is either pi radians or 180 degrees. Recognize that those are, of course, the exact same thing. And so our ordered pair, r theta, could be 6 pi. You could also use degrees, 6, 180 degrees. That's okay. Just make sure that if you write it in degrees, you write with the degree symbol. All right, well, let's do another easy one. What else could we do? Well, we could also do 6 and a coterminal angle, so that's pi plus 2 pi, or 3 pi. So that's another equivalent way to write this. What else could we do? We could also use negative radii. And so if I were to take and use my radii to be negative 6, then I start here and I go to negative 6, but then how much do I rotate? I rotate none. And so notice that this one, interestingly, in radians, is the same, the rectangular coordinate negative 6, 0, and the polar coordinate negative 6, 0. And so remember that I could also write this as negative 6, 0 degrees. And since we said 3 other ways, then we could also use a coterminal angle for 0 rotational. a 0 rotational angle, and that could also be written as negative 6, 2 pi. Alright, so now let's try 0, negative 4. Let's plot 0, negative 4, xy coordinate plane. If I call this negative 4, then my ordered pair 0, negative 4 is right there. Well, then moving from the pole to that point gives me a radius of what? For 4. And then if I consider the first theta that I can think of, that's going to be a theta equal to 3 pi halves. So then 0, negative 4 in polar coordinates is 4, 3 pi halves. Now, what's another coterminal angle we could use? We could also use negative rotation angles. So if I were to rotate this way, that rotation is a theta of negative pi halves, and so this could also be written as 4 negative pi halves. Let's say that I want to consider using negative radii. Well, if I use negative radii, then that would be a negative 4, and then to get from negative 4 to this point would be a rotation of pi halves. And then, of course, if you were to take that negative radii, negative 4, and rotate back the other way, that would give us a rotation of negative 3 pi halves. So negative 4, negative 3 pi halves. Alright, let's try some a little more complicated. Let's say that I'm given the ordered pair 3, 3. Well, rectangular coordinate point. Let's graph it. And so 3, 3, rectangular coordinates right there. Well then, how can we find r theta? Well, polar coordinates r theta, we need to find a radius, and we need to find a rotational angle theta. Superimpose the right triangle. We can find some x value, we can find some y value, we can find the r, and we need to find theta. Well, notice that we now have that x is 3. It was given to us. Y is 3. And so what's r? R is then going to be equal to the square root of 3 squared plus 3 squared, x squared plus y squared, which is then going to be the square root of 18. But square root of 18 is really 3 root 2. So now we have the radius being 3 root 2. Well, we also need to find the rotational angle theta. Well, how can we find theta? Well, I recall that tangent of theta is equal to y divided by x, but now I know that y and x are 3 and 3. So 3 divided by 3. So now I want to know tangent of theta is equal to 1 when I can take tan inverse of both sides. And so theta is equal to tan inverse of positive 1. That means that theta is going to be root 2 divided by 2. And so now I know tangent inverse of 1 occurs at a rotational angle of 45 degrees, or pi fourths. And so my first polar coordinate is 3 root 2 pi fourths. Of course, that's exactly the same thing as 3 root 2, 45 degrees. Well, what else could we do? We could, if we wanted, use negative rotational angles. So how about 3 root 2 and negative 7 pi fourths? Or, of course, that's the same thing as 3 root 2, 315 degrees. Then once I have those, I can say, okay, well, what if I used a radius of negative 3 root 2? What would my rotational angle be then? Alright, so if I do negative 3 root 2, negative 3 root 2 is somewhere over here. I could do positive rotations from here to here, and that would be 5 pi fourths. I could also do my rotational angle this way, which would be negative 3 pi fourths. And so recognize multiple ways to write this. Alright, let's do another. 2 root 3, negative 2. Draw it first. 2 root 3, that's positive, so if I call this 2 root 3, then negative 2, so it goes down 2, and so 2 root 3, negative 2. There's my ordered pair. So then what do we need to do? We need to draw our triangle. And so this, well, we know what our y value is. Our y is negative 2. Our x value is 2 root 3. Then what is r? Well, Pythagorean theorem. R is equal to the square root of x squared, which is 2 root 3 squared, plus y squared, that's negative 2 quantity squared. And so I get that this is the square root of 4 times 3, or 12, plus negative 2 times negative 2 is positive 4. 12 plus 4 is 16. Square root of 16 is 4. So now I have a radius. Radius is 4. So for polar coordinates, r theta, I get 4. And let's just do the first one I see, which is a rotational angle. That's a negative rotational angle of theta, but let's figure out what that is. Well, tangent of theta is equal to y over x, or negative 2 over 2 root 3, which does reduce to be tangent of theta is equal to negative 1 over root 3. So then I can take tan inverse of both sides, and that gives me that theta is equal to tangent inverse of negative 1 over root 3. Then recall that that is equal to negative 30 degrees, or negative pi sixth, depending upon if you want to work in radians or degrees. So, my first answer, 4 negative pi sixth. Then to get another one, we can quickly do a coterminal angle. How about 4 and... So a second one, we can use a coterminal angle. That is, if I go from here to here, what's that distance we just traveled? Well, that's 11 pi sixths. We could also use negative radii, so how about negative 4? And if we go back to negative 4, and then we go from there to here, well, what distance did we travel there? That's going to be a distance of 5 pi sixths. Or we could also go the other direction, in which case that would be negative 4, 7 pi sixths. Now going the other way, let's say that we want to convert polar coordinates to rectangular coordinates. Truth is going from polar coordinates to rectangular coordinates is much, much quicker, because all you have to do is use our definition of x and y, where specifically x is equal to r cosine theta, and y is equal to r sine theta, and then we get our rectangular coordinates very quickly. And so our rectangular coordinates here are going to be, specifically, x will be r cosine theta, or 10 cosine of pi thirds. And then y is going to be 10 sine of pi thirds. But we can simplify this a little bit, and so cosine of pi thirds, that's going to be 10. Cosine of pi thirds is a half. And then 10 sine of pi thirds. Sine of pi thirds is root 3 over 2. And so we can simplify a little bit further. 10 divided by 2 is 5. 10 divided by 2 is 5, so that's 5 root 3. And so here are our rectangular coordinates for the polar coordinate 10 pi thirds. Well, then if I have negative 5, 135 degrees, well, of course, you can just jump right to it. That is negative 5 cosine of 135 degrees is our x-coordinate, and negative 5 sine of 135 degrees is our y-coordinate. Well, then cosine of 135 degrees, using our unit circle, that's going to be negative root 2 over 2. So I get negative 5 times negative root 2 over 2. And then my y-coordinate, negative 5 sine of 135 degrees, that's going to be positive root 2 over 2. And so that's negative 5 times root 2 over 2. And so then we get that this is not negative anymore. Negative times negative is positive, so that's 5 root 2 over 2, and negative 5 root 2 over 2. Now, one thing that I am skipping over here, but we could definitely do it, is to plot the polar coordinates. And you could double check yourself. So 10 pi thirds go out to 10. Rotate a distance of pi thirds. 10 pi thirds should be about right here. Well, 5 root 3, they're both positive. That's a pretty quick, easy error check. Also, negative 5, 135 degrees. Well, that's the situation where I go to negative 5, and then I rotate counterclockwise 135 degrees, so I'm over here somewhere. We'll notice that this is a positive x value and a negative y value, and that's exactly what we got, so pretty quick, easy error check. Let's do these the same way. If we want to convert these to rectangular coordinates, then, of course, that's just going to be 5 cosine of pi fourths, and then the y-coordinate is 5 sine of pi fourths. Well, cosine of pi fourths is root 2 over 2, so this is going to be 5 root 2 over 2. And sine of pi fourths is also root 2 over 2, so that's going to be 5 root 2 over 2. Well, recognize that if I graph this polar coordinate, I go out 5 and rotate pi fourths. It's in first quadrant, they're both positive. Seems reasonable. Then if I've got negative 2, 5 pi 6, maybe let's graph it to double check ourselves. So negative 2, and then a rotation of 5 pi 6 puts us over here. Okay, so let's see what we get. Using conversion to rectangular coordinates, x is going to be r cosine theta, and y is going to be negative 2 sine theta, or 5 pi 6. Well, what's cosine of 5 pi 6? Cosine of 5 pi 6 is negative root 3 over 2, so this is then going to be negative 2 times root 3 over 2. Of course, that is negative. And then negative 2 sine of 5 pi 6, well, that's going to be a half. And so then I can simplify a little bit. Negative times negative is positive. 2 divided by 2 is 1. I get that that's root 3. And then negative 2 times a half is negative 1. Positive x value, negative y value. It's reasonable to believe that this is correct. Now furthermore, not only do we have a way to convert between coordinate points in the different graphing systems, but we also have the ability to convert our equations. And so the deal is that some curves are going to be much simpler to work with in polar form than rectangular. Essentially anything that has a nice rotational shape. Others are going to be simpler in rectangular form. So now we want to convert each of the following to polar equations. Now, remember, what do we have under our tool belt? Well, we've got Pythagorean theorem. R is equal to the square root of x squared plus y squared. We also know that x is equal to r cosine theta, and we know that y is equal to r sine theta. Now we might want to manipulate these in some form or fashion, but I claim that this is all we need. So specifically, I see x squared plus y squared. Well, x squared plus y squared is there. Well, what if I wanted to get x squared plus y squared by itself in this equation here? Well, just square both sides, right? You're just putting it back in the normal form of Pythagorean theorem. That is, r squared is equal to x squared plus y squared. Well, if that's the case, the fact that I have x squared plus y squared here, that means that's really r squared. So r squared is equal to 25. If you happen to recall what x squared plus y squared equal to 25 is, it's specifically the graph of a circle centered at the origin with radius square root of 25 or 5. Well, notice that in this format here, if I take the square root of both sides, then I get that r is equal to 5. And if I were to try to graph r is equal to 5, well, if the radius is 5 here, then the radius being r equals to 5 for all thetas is just a circle with radius 5. And so circles are really nice things to graph using polar equations. Alright, here I've got 2x minus y is equal to 5. Well, x is equal to r cosine theta, so that's 2r cosine theta minus, well, y is r sine theta, so that's r sine theta is equal to 5. Now, often enough, when writing equations in polar form, we usually write them as r equals. And so if you wanted to solve this for r, you could factor out at r, and you would get r times 2 cosine theta minus sine theta is equal to 5. Divide both sides by 2 cosine theta minus sine theta. 2 cosine theta minus sine theta. And you could get a polar equation or a polar function. R is equal to 5 divided by 2 cosine theta minus sine theta. But recognize that doing what we did first is perfectly fine, but these are just equivalent ways to write the exact same equation. Okay? Alright, what if I have y is equal to 3? Well, once again, I know that y is equal to r sine theta, so it's easy as replacing y with r sine theta. So that's r sine theta is equal to 3. If I divide it by sine of theta, r is equal to 3 divided by sine of theta, but I just need to get a polar equation, and I've done it. Same thing for this next one. Replace y with r sine theta, so that's going to be r sine theta quantity squared is equal to 3 times r cosine theta. And so then we have this. If we wanted to do some manipulation and try to solve for r, we could try to and see if we could. And if we can, then you could write it as a function in terms of r, but they just want an equation, and so we're good. Recognize that in this one, we're converting from polar to rectangular. And so let's write it again. R is equal to the square root of x squared plus y squared. And remember that x is equal to r cosine theta, and y is equal to r sine theta. And so r being equal to 4, well, just replace r with square root of x squared plus y squared. Square root of x squared plus y squared is equal to 4. If you're trying to get it to a form we might remember from rectangular coordinates, you could square both sides, and then you would get that x squared plus y squared is equal to 4 squared, or 16, which specifically is the circle centered at the origin with radius 4. Well, r is equal to 4 is exactly that. Notice here that we have r cosine theta is equal to 6. Well, r cosine theta is just x, so this is x is equal to 6. Now we're going to play some tricks, but once again, remind ourselves, if r is equal to the square root of x squared plus y squared, we can of course do algebra to these things, and x is equal to r cosine theta, and y is equal to r sine theta. Because we have equations, as long as you do arithmetic in the same fashion at both sides, then there's some manipulations that you can do to get equivalent statements. And so for this first one, r is equal to 2 cosine theta plus 3 sine theta, recognize that I need to get rid of the r's and the thetas. But I also have this problem, and the problem is that I need r cosine theta and r sine theta to be able to do something. So what can we do? We can multiply both sides by r. We're just doing some algebra, and so if that's the case, then this becomes r squared is equal to 2r cosine theta plus 3r sine theta. Well, this is much better because now I replace r with square root of x squared plus y squared, but that's squared. Then it's equal to 2r cosine theta is x plus 3 times r sine theta, but r sine theta is y, and so then I get that x squared plus y squared is equal to 2x plus 3y. We just need an equation, and there we are. If I have r is equal to 4 sine theta, play the same trick, multiply both sides by r. Then I get that r squared is equal to 4r sine theta. Notice that r sine theta is y, and r squared is, well, if you want, you could rewrite that as r squared is equal to x squared plus y squared to save a step, and then that's going to be x squared plus y squared is equal to 4y. And so there we are.